Today we are going to learn the derivative of log functions, and we're going to start out with the natural log function, which is y equals ln x. And we are going to use our handy dandy rule again about the derivative of an inverse function, right? If just a reminder, right? If g is the inverse of x, then let's say g is the inverse of f, right? Then we know that g prime of x is equal to 1 over f prime of g of x. Okay, that's our derivative of an inverse function. So we are going to think of this as our g, right? This is the one we want. So g of x is ln x. And we know that the inverse of ln x is, so f must be e to the x. Okay? So we're going to figure out what g prime is using this formula. So we need f prime with g inside. So we'll first start with f prime of x. I love e to the x because the derivative is e to the x. And then it says to plug in g of x. So f prime of g of x would be equal to e to the ln of x, right? I would plug in g is my new x. It goes up here. And this whole thing simplifies to just x, because these two things are inverses of each other, and when I compose them in either direction, I should get out x. So that means that g prime of x is equal to 1 over f prime of g of x. And that means that really we have, this is f prime of g of x, that g prime of x is 1 over x. Right, so this is just the rule, and then we already found this, so it's just 1 over x. So we now know that the derivative of the natural log of x is equal to 1 over x. Okay, now this can go a little further. Of course, there's a chain rule. So if, in fact, I have something else inside of here besides just x, we'll just call it g of x, then this is 1 over this same thing, g of x, and then, of course, times the derivative of the inside is the chain rule. So a lot of times we just write these as g prime of x over g of x. Okay, now I'm going to do the same thing for a log function. Okay, so basically a log base b. So if y equals log base b of x, we did the natural log of x already. So the inverse of log base b of x, right, would be b to the x equals y. So this is going to be my f of x, and this, the one that we want to find, is my g of x. And again, we know that g prime of x is 1 over f prime of g of x. This is our derivative of the inverse formula from a couple lectures ago. So let's see, we know that we're going to need f prime of x, right? So I know that my g prime of x will be 1 over, let's do this part here now. So f of x is b to the x, or b to the x. So f prime of x is b to the x ln b, right? Because this is a not e, so we also tack on the natural log. And so now we also need f prime of x. Actually, we need f prime of log base b of x, right? Because that's our g of x. So we have b to the log base b of x ln b. And just like the e to the x, this is b to the log base b of x. This is also x. So my f prime of log base b of x is equal to just x ln b. Okay, so that means that now this is my f prime of g of x right here, right? Because this is my g of x in here. So basically this will be 1 over x ln b. Okay, so that works for log base 10, log base 3, whatever it is. And just like if I had the log base, right, if this were the log base b of something else, then the derivative, so let's just write this first. The log base b of x is 1 over x ln b. So it's kind of like, right, when we were doing the derivative of b to the x, we tacked on the extra ln b. Here we're dividing by the ln b. Okay, and then also if I have a chain rule situation that the derivative of log base b of g of x, right, then this would just be 1 over g of x, this is my x, ln b, and then times g prime of x. So we could write it as g prime of x over g of x ln b. Okay, so let's just work some examples. Okay, so the first one, we have the derivative, and we're going to do the derivative of, obviously, chain rule. So this is like my giant g of x. So the derivative of this, f prime of x, is 1 over this whole thing, 1 over 2x to the fourth minus 6x plus 1, and then times the derivative, which I can just put on top with this 1. So the derivative of the bottom will be 8x cubed. Let me take away that 1, and then minus 6. And there is my derivative. So sorry, there was a 1 up there, and that's gone now. Okay. Now, because we're working with natural log functions, we can actually, now that one I couldn't really simplify anymore, but there's rules for my natural log functions that will allow me, in like a case like this particular one, to break it apart, right? So my natural, or my log rules tell me that if I have things multiplied together, then I can write them then as the natural log of this plus the natural log of that. And if I have division, then I can write it as minus the natural log of this, right? And that works with all the bases, not just natural log. It's called the product property of logarithms or the quotient property. So we can write this, I'm just rewriting it, I'm not doing the derivative now, as the natural log of x cubed plus the natural log of the cosine of x minus the natural log of x squared plus 1. Okay. Now this is going to allow me to do my derivative in smaller bite-sized steps. So then I'm going to do, now I have plus in between them all, so I can just do individual derivatives. So then the derivative of the natural log, actually I could make this a little bit simpler still. For this one, actually I can pull down the exponent and write it in front. Okay, so now I've just got 3 times the natural log of x. So its derivative is just 3 over x, right? The derivative of natural log of x is 1 over x. The 3 was sitting out front, so it just gets multiplied. Then I have plus, I'm going to have cosine in the bottom, right, because it's 1 over this thing. The derivative of cosine then is negative sine, so I'm going to put that on top. And then I have minus, then I have 1 over this thing, so this will be in my denominator, x squared plus 1, and I put the derivative on top, which is 2x. And there is my derivative. So you do not have to combine them into a single denominator. Just leave it like this. It's perfectly fine. Let's find the slope of the tangent line at x equals 1. Okay, so this time we have a log of base 2, so we're going to need an extra. So y prime equals, now the original is just the same, so I'm going to have 3x plus 1 down here, and then I'm also going to have the 3 on top from the derivative of this. So this is just like if it was ln, but then also down here I have to tack on the natural log of 2 because 2 is my base. Okay, so if I wanted y prime of 1, y prime of 1 is just going to give me, now there should be parentheses around there, 3 over the natural log of 2, and then when I plug in 1, I'm going to get 4 natural log of 2. Okay, and that is just a number I can put in my calculator. Okay, so let's try another one. We have f of x equals the log of cosine of x. So initially I'm just going to treat it like it's ln, so I know that it's going to be a cosine in the bottom, right, and a negative sign on top because that's the derivative, and then times, now this is log with nothing said, so we're going to assume it's base 10, so this also has, oops, I wrote log instead of ln of 10. And there's my derivative. So I could technically call it, if I really wanted to, negative tangent of x over the natural log of 10, if I really wanted to. It's perfectly fine the way it is, though. All right, so that is doing the derivatives of log functions.